The C-5 Galaxy has long been a powerhouse in military aviation, but with its latest upgrades, it's on another level. The U.S. Air Force has taken this giant and pushed it even further, boosting performance, efficiency, and capabilities in ways that have stunned experts worldwide. From advanced avionics to extended range and improved logistics, these upgrades aren't just routine, they're game-changing. So, what's new, and why is the world taking notice? Let's break down how the U.S. has upgraded the C-5 Galaxy and why it's making waves globally. More than just an aircraft, the Lockheed C5 Galaxy is a symbol of American ingenuity, ambition, and military dominance. For over 5 decades, it has been a cornerstone of global logistics, enabling the U.S. to project power and deliver humanitarian aid worldwide. Its massive size, range, and versatility have cemented its legendary status in aviation history. The C5 story begins in the 1960s, amid the Cold War and Vietnam War. The U.S. military needed a bigger, stronger transport aircraft. The Douglas C-133 Cargo Master was aging, and while the Lockheed C-141 Starlifter was reliable, its cargo hold was too small for the Army's largest vehicles and equipment. Tanks, helicopters, and oversized gear simply didn't fit. The military required greater range, higher performance, and, most importantly, a massive cargo bay. This led to the CX-4 project in 1962, with Lockheed, Boeing, Convair, and Douglas submitting designs, each featuring 6 engines. But by 1963, the Army realized the CX-4 wasn't enough. The project evolved into the CX-HLS program, demanding an even larger aircraft powered by 4 high-performance engines. With a max payload of 180,000 pounds and a cruising speed of Mach 0.75, about 500 miles per hour, the cargo bay needed to be 100 feet long, 17.2 feet wide, and 13.5 feet high, big enough to handle the largest military equipment without major disassembly. Once specifications were finalized, the U.S. Air Force issued a formal request for proposals in April 1964. 5 aircraft manufacturers, Boeing, Lockheed, Douglas, General Dynamics, and Martin Marietta, submitted designs, while General Electric, Curtiss-Wright, and Pratt & Whitney competed to provide the engines. After a thorough review, the Air Force narrowed it down to Boeing, Lockheed, and Douglas. All 3 designs shared key similarities, like a raised cockpit for nose loading. Boeing and Douglas opted for a pod-like cockpit on top of the fuselage, while Lockheed's design extended the cockpit profile along the fuselage, giving it a unique egg-shaped cross-section. The C-5 Galaxy featured swept wings and front and rear cargo doors for faster loading and unloading. Lockheed's design used a T-tail, while Boeing and Douglas opted for conventional tails. For engines, General Electric and Pratt & Whitney were considered, but GE's TF-39 stood out as revolutionary. Early jet engines had bypass ratios under 2:1, meaning most air flowed through the core. The TF-39, with an 8:1 bypass ratio, significantly boosted thrust and fuel efficiency, key for a heavy airlifter. Boeing's design was technically superior, but Lockheed's was the most cost-effective. In September 1965, Lockheed won the contract, with GE's TF-39 chosen as the engine. By December, Lockheed began building what would become the C-5 Galaxy. The first prototype, the C-5A Galaxy, rolled out of Lockheed's Marietta, Georgia, plant on March 2, 1968. With its high wing, distinctive tail, and raised cockpit, it was unlike anything before. Its swing-nose cargo door allowed easy loading of oversized cargo. On June 30, 1968, test pilot Leo Sullivan flew its maiden flight under the call sign 8303 Heavy. The C-5 wasn't just about size, it revolutionized air transport. Its massive cargo bay could carry tanks, helicopters, and more without dismantling. The front and rear cargo doors allowed simultaneous loading, streamlining operations. Despite losing the contract, Boeing adapted its design into the Boeing 747, the world's first jumbo jet. Introduced in 1970, the 747 transformed commercial aviation with its large passenger capacity and range. Over 1,500 were built before production ended in 2022, marking 54 years of manufacturing. The C-5 Galaxy remains an engineering marvel, 247 feet long, with a 222-foot wingspan. Its 34,000 cubic foot cargo bay can fit a main battle tank, 6 Apache helicopters, or 24 MATT Versus. Its high-lift wings and powerful engines enable a 500,000 pounds cargo capacity. The hinged nose and tail doors allow dual-end loading, while its kneeling landing gear simplifies the process. With 28 landing gear wheels, the C-5 operates on unprepared airstrips as short as 4,000 feet, vital for deploying forces to remote areas. It set records soon after entering service, becoming the first aircraft to carry over 1 million pounds. In 1974, a C-5A set a record for the heaviest airlift during a humanitarian mission to Iran. The upgraded C-5M Super Galaxy later shattered 41 world aviation records, including time to climb and payload capacity. However, early C-5s faced challenges. Wing cracks from structural stress required costly reinforcements, and the TF-39 engines, while groundbreaking, had reliability issues. Though the TF-39 engines introduced the high-bypass turbofan concept, making the C-5 more fuel-efficient than earlier military transports, they had drawbacks. They lacked the long-term reliability and power needed for demanding missions, prompting the Air Force to launch a major upgrade program. The biggest improvement came with the General Electric CF6 engines in the C-5M Super Galaxy. Evolved from the TF-39, the CF6 was more powerful and refined, benefiting from decades of advancements in both military and commercial aviation. Proven on aircraft like the Boeing 747 and DC-10, the CF6 offered the reliability and efficiency needed to modernize the C-5 fleet. Compared to the TF-39, the CF6-80C2 engines deliver 22% more thrust, increasing payload capacity and shortening takeoff distances. They also improve climb rates, allowing the C-5M to reach cruising altitude faster, critical in combat zones. More importantly, they boost fuel efficiency, extending range by about 1,000 nautical miles, reducing refueling stops, and enhancing mission flexibility. Maintenance was another key advantage. The aging TF-39s were costly to repair due to scarce spare parts, while the widely produced CF6 benefited from ongoing material and design improvements. As a result, the CF6 powered C-5M saw a nearly 40% increase in mission readiness, making it more reliable for critical operations. Today, the Super Galaxy can haul 120,000 pounds of cargo over 7,000 miles without refueling, with aerial refueling giving it virtually unlimited range. Since its 1970 debut, the C-5 has been vital in nearly every major U.S. military operation. Designed to transport oversized cargo globally, it plays a key role in wartime logistics, humanitarian aid, and disaster relief. With a max payload of 281,000 pounds and the ability to operate from austere airfields, it ensures rapid global mobility. During Operation Desert Storm in 1991, the C-5 delivered tanks, helicopters, and supplies to the Persian Gulf, supporting the largest airlift since World War II. Its long range and heavy lift capabilities helped the U.S. rapidly build up forces, contributing to victory over Iraq. After September 11th, the C-5 was crucial in deploying troops and equipment to Afghanistan and Iraq, transporting everything from combat vehicles to ammunition. Its ability to carry massive loads across continents without refueling made it one of the most valuable logistics assets in the global war on terror. Beyond combat, the C-5 has been essential in humanitarian efforts. Following the 2004 Indian Ocean tsunami, it delivered thousands of tons of food, water, medical supplies, and mobile hospitals to devastated regions. During the COVID-19 pandemic, It once again proved indispensable by transporting vital supplies worldwide. Across the globe,